Imagine the universe as an immense, shadowy ocean, an infinite realm that stretches far beyond what our minds can grasp. Within its vastness lie countless enigmas, spinning galaxies, and ancient beams of starlight that have journeyed across billions of years to reach our eyes. Throughout history, humanity has lingered at the edge of this cosmic sea, staring out in awe and wonder. The night sky has always beckoned us, its twinkling lights sparking our imagination and fueling our deepest questions. We've caught glimpses of distant brilliance and swirling cosmic currents, always wondering, what lies beyond? Are we truly alone in this endless expanse? What secrets do those remote stars conceal? And could there be other shores, other watchers, peering back at us? These questions are our driving force. They fuel our science and exploration, urging us to look deeper, reach farther, and never accept the boundaries of our current knowledge. For generations, our instruments were simple, our perspective limited, like children peeking through a tiny keyhole, catching only the faintest hints of the wonders that lay beyond. Yet, our curiosity is unstoppable. It refuses to be confined. With every breakthrough, every answer, and every new puzzle, our hunger to know more only grows. We construct ever more powerful telescopes, embark on bold missions, and push the boundaries of the unknown. Our spacecraft venture into the darkness, carrying our hopes and questions to the very edge of possibility. Each discovery is a step away from the familiar shore, learning to navigate the cosmic ocean. We chart new worlds, unveil hidden galaxies, and find planets that could cradle life. Today, August 16th, 2025, we've made a historic leap. The news reverberates worldwide, scientists rejoice, and the world pauses in anticipation. We've uncovered something that transforms our understanding of the cosmos. A revelation so extraordinary, it changes the very questions we ask and how we see our place in the universe. The universe is more astonishing, more intricate, and perhaps more vibrant than we ever dared to believe. Every answer opens new mysteries, and each discovery reminds us how much remains unknown. The shoreline we once knew now seems even smaller. As we venture further into the cosmic ocean, we realize our journey is just beginning, and the universe is waiting for us to uncover its infinite marvels. To see the unseeable, you need a special kind of eye, the James Webb Space Telescope. Unlike Hubble, which showed us the universe in visible light, Webb sees in infrared, revealing hidden nurseries where stars and planets are born. Webb's mission: look for the first light, watch galaxies evolve, witness star and planet birth, and study exoplanet atmospheres for signs of life. Its giant, gold-plated mirror and sun shield let it capture the faintest whispers from the edge of the universe. Webb has already rewritten textbooks, revealing galaxies and nebulae in unprecedented detail. But last week, it found something no one expected, something out of science fiction. The universe had a secret to share. The target was Kepler 186f, a rocky, Earth-sized exoplanet orbiting quietly in the habitable zone of a dim red dwarf star, some 500 light-years from Earth. This distant world, shrouded in mystery, had long captured the imagination of astronomers searching for signs of life beyond our solar system. Its size and location made it a prime candidate, a place where liquid water might flow, and where the conditions for life as we know it could exist. The James Webb Space Telescope was tasked with a delicate mission: to observe Kepler 186f as it passed in front of its star, capturing the faint telltale changes in starlight that filtered through the planet's atmosphere. By analyzing the starlight, scientists could search for the chemical fingerprints of life, tiny clues hidden in the spectrum, waiting to be discovered. The team expected to find familiar molecules: water vapor, carbon dioxide, perhaps a trace of methane. These would be promising signs, hinting at a world that could support life, or at least the chemistry necessary for it. Each molecule would tell a story about the planet's climate, its potential for habitability, and its place in the cosmic tapestry. But as the data streamed in, something extraordinary appeared: a sharp, unmistakable absorption line, stronger and more defined than anything they had anticipated. It didn't match any known inorganic molecule, nor did it fit the expected patterns of a barren world. The signal was both alien and familiar, a puzzle demanding to be solved. At first, some thought it was a glitch, a fleeting artifact in the data. But repeated observations confirmed its presence. The signal was real, a whisper from across the void, persistent and undeniable, echoing through the silence of interstellar space. The unthinkable had been detected, the spectral signature of chlorophyll, the green pigment that on Earth is the foundation of photosynthesis and the engine of our biosphere. This was not just a simple organic molecule, but the very pigment that powers the transformation of sunlight into life. On Earth, chlorophyll is the signature of thriving ecosystems, of forests and fields teeming with energy and growth. This wasn't just a hint of life. It was evidence of a planetary-scale biological process, a biosignature so strong it could only come from a world alive with photosynthetic organisms. The discovery suggested vast, green landscapes, perhaps alien forests, or oceans of microscopic life, transforming the planet's atmosphere on a global scale. The cosmos had spoken, and its message was clear. In the vastness of space, life had found a way to leave its mark, to send a signal across the darkness. Life had left its mark on another world. For the first time, humanity glimpsed the possibility that we are not alone, that the universe is richer, stranger, and more alive than we ever dared to dream. Dr. Eris Thorne sat quietly in the softly humming lab, his eyes fixed on the streams of data pouring in from the Webb telescope's latest observation run on Kepler 186f. He expected another routine day, just more numbers to sift through, more graphs to analyze. The familiar glow of the monitors cast shifting patterns across the walls, a silent testament to the countless hours spent searching for something extraordinary in the ordinary. But then, his colleague Lena leaned in, her brow furrowed in concentration. She pointed to a sharp, unmistakable spike in the spectrum, a deep, clean anomaly that stood out like a beacon. It was unlike anything they'd seen before, a signal that seemed to defy all their expectations and previous experience. The team sprang into action, running every diagnostic they could think of. They checked for instrument errors, software glitches, and even cosmic interference. Side by side, they compared the new data with previous observations, hoping to find a mundane explanation. But the signal remained, persistent and unyielding, refusing to be dismissed. What was even more remarkable was its timing. The signal only appeared when Kepler 186f transited its star, suggesting it was coming directly from the planet's atmosphere. This was no random blip. It was a pattern, a clue pointing to something extraordinary. Driven by curiosity, Lena expanded the search. She began cross-referencing the spectral signature with vast biochemistry databases, searching for any known molecules that could produce such a signal. Suddenly, the computer chimed, a perfect match. The signature belonged to chlorophyll F, a pigment known to be adapted for absorbing the dim red light of red dwarf stars. It was a molecule associated with life, with photosynthesis, with the very process that powers living worlds. The realization hit the team all at once. The room fell silent, the air thick with anticipation and disbelief. On their screens was evidence of the impossible, a biological marker on a distant world. No one left their station. Through the night, the team worked tirelessly, double-checking every calculation, scrutinizing every detail, determined to rule out any error. The weight of what they might have found kept them focused and awake. At last, the evidence was irrefutable. The signal was real, robust, and unmistakably biological in origin. Every test confirmed it. The magnitude of their discovery began to sink in. They were witnessing a moment that would change the course of science and humanity, a breakthrough that would echo through history. The unthinkable was no longer just a possibility. It was now undeniable fact. The data spoke for itself, clear and unambiguous. The universe had revealed one of its greatest secrets, a living world orbiting a distant star, its atmosphere alive with the signature of life. In that moment, humanity's place in the cosmos shifted forever. The stars no longer seemed so distant, and the possibility of life beyond Earth became a reality that would inspire generations to come. The news raced through the scientific community, met first with skepticism, then with mounting excitement. Extraordinary claims demand extraordinary evidence, and every alternative explanation was tested and failed. Independent teams worldwide scrutinized the data, searching for flaws. No known inorganic process could explain the signal. Only chlorophyll fit. Webb's follow-up even detected seasonal changes, matching planetary cycles of growth and decay. When NASA's announcement came, it was more than a discovery. It was confirmation of a planetary-scale biosignature. We had found strong evidence of a living, breathing world, 500 light-years away. The unthinkable was now reality. Humanity was no longer alone in the universe. The cosmos had given us an answer. We had found another biosphere. The search for life had succeeded. This is a watershed moment, shattering the assumption that Earth is unique in hosting life. The presence of chlorophyll-like molecules on Kepler-186f suggests photosynthesis evolved independently elsewhere. Life may be common wherever conditions are right. For science, it's a revolution. Biologists, geologists, and climatologists now have a second living world to study, even from afar. Philosophically, it reframes our existence. We are not the only act in the cosmic theater. The universe is not a sterile void, but a garden with many flowers. New questions arise. What kind of life thrives there? Is it simple or complex? Intelligent? The discovery of a biosphere is just the beginning. We've moved from asking, "Are we alone?" to "Who are our neighbors?" The silence of the cosmos was never emptiness, just the limit of our hearing. What happens now? This discovery will spark a new golden age of exploration. Plans for even larger telescopes are already underway, aiming to map distant worlds in detail. The search will shift from finding habitable planets to cataloging living ones. SETI will focus on Kepler-186f, listening for signs of intelligence. The odds of finding life elsewhere in our solar system now seem higher. Probes to Mars, Europa, and Enceladus will be equipped with new life detection tools. This is a call to action, a challenge to explore further and dream bigger. One day, we may send a probe across 500 light-years, carrying our greetings to another living world. The journey now has a destination. We have found another shore, and we must go see who lives there. The universe has spoken, sharing a secret across the gulf of space and time. Life is not a solo performance. We are part of a cosmic family. This knowledge changes everything, filling the darkness with possibility. We do science for moments like this, when discovery touches the soul of humanity. Tonight, go outside and look up. The stars are the same, but your understanding is forever changed. You now know there is at least one other living world. The universe is not just gas and fire, but life. Let that wonder fuel your curiosity. Keep looking up.